Okay, my voice is audible. Somebody can respond.
Yes, sir.
Okay, thank you. So let us start one of the topic from this suspension system and modern trends in automobile. So just I will revise some of the part whatever we have studied yesterday. So we have seen these characteristics of suspension system. First one is road holding. Then we have seen principle, definition, goal, and how to provide solution for this road holding characteristics. Then cornering, and this is first one is road isolation. Okay. Then we have seen requirements of suspension system, which includes minimum weight, then a minimum wheel bounce, minimum tire wear, and deflection consistent with required stability. So, and with respect to cost, whatever suspension system, it should have low initial cost, it should have low maintenance as well as operating cost. And the last requirement that is important one, that is compatibility, that is under the compatibility. So it is related with the other vehicle components such as tire, frame, steering linkage. So it should not provide any trouble to other components of the automobile. Then next we have seen regarding sprung and unsprung mass. So basically whatever weight of the mass which is supported by the spring, that is called as a sprung mass, and weight which is not supported by the spring, that we are going to call it as a unsprung mass. So related to this, what we have seen, various components under the sprung mass: frame, then body, then engine and transmission system. So, and under unsprung mass, so what we have seen, so rear axle assembly, steering knuckle, so that is below the spring. So shock absorber, other springs, those are under the sprung mass. So this we have seen. Then we have seen basic suspension movements, which include bouncing, then rolling and pitching. So these are the figures to understand what are the basic suspension movements. Then we have seen significance of pitching moment. Then we have started regarding components of suspension system, which includes springs and the damper. Okay. So this part we have started. So this is first component, and which is required to absorb the shock, and that component is nothing but spring. So this we have seen the springs used in heavy duty vehicles, that is leaf spring, and this is also used in some of the light motor vehicles such as jeeps, then small tempos. So these springs are referred as laminated leaves. So because these are used, steel strips are used in fabricating such beam, such a flexible beam, which will help in suspending large wheels as well as able to absorb the road shocks. So what we have seen in this, so there are strips, steel strips, and there is difference in their length. So first it is called as a main leaf, so or major leaf, and below that leaf laminated strips of reducing length. So such springs we can also called as semi-elliptical springs, as this is camber is provided for this. So these leaf springs are made up of steel, flat in nature, so to support the axle and to suspend the axle. So both can be done with the help of this leaf or laminated springs. So in some of the cases for suspension system, this axle is above the leaf spring. So in some of the travels, so such construction can be seen with respect to the suspension system. So this each strip, so 1, 2, 3, again this 1, 2, 3, this is called as a leaf. This is called as a leaf. This is the bracket at the front. It is used to hang the spring. This is at the rear, which is also used to hang the spring. This one is shackle, which is used to compensate change in the length of the spring. So when there will be change in the length of the spring, so when the wheel confronts any obstacle or encounters any bounce in the road, so what will happen? So spring is going to expand because impact will be at this point. Impact will be at this point. So again, this length is going to increase. How to compensate? By providing this shackle. And opposite it the case. So whenever there is pit in the road, so small pit in the road, even though at that time there will be contraction of the spring, and for that also there should be reduction in the length of the leaf spring. So basically such shackle is provided to accommodate change in the length. So you can relate this leaf spring or total assembly of leaf spring with this actual image shown in this figure. And additionally, you can able to see this is another one figure which indicates a main leaf, and this is nothing but the helper spring. So whatever way this main leaf spring assembly, it is connected with the help of one hanger at the front and one cycle at the rear end, and in addition to that, one small assembly similar in construction is provided above this main leaf, and that is called as a helper spring. That is called as a helper spring. So such helper springs used to weigh more load. So those will come into action whenever load increases beyond certain limit. So you might have seen such helper springs for the sugarcane weighing tractors. So whatever tractors you might have seen for trailer which is attached behind the head. So for that tractor trailer, so such helper springs are provided. So that will support additional load, and such helper spring will be provided. So for the vehicle which needs to weigh beyond 10 to 15 ton capacity load. So this is main leaf and this one is the helper spring. So here it is written helper spring. So other things are same. Okay. Now, what are the advantages with respect to this helper springs, and what is actually use of this helper spring? And so these helper springs, in addition to main leaf, are provided to carry more load, but you should remember that these helper springs comes into action when load is increased. So generally helper springs are used in case of commercial vehicles, and that too on rear suspension system. Oh, 1 minute. Okay. So this is about leaf spring. Now let us see springs in that coil springs. Here you can see it's a structure. So some of the models, then you can see some of the design related things. such as diameter of this coil or wire, steel wire. Then here you can see 0.410 inch, 10.5 mm. Here it is increased one. It is 12.2 mm. Here again decreased one. So at the center, it is increased. So that is again related to the design consideration. So such coil springs are used in case of independent suspension system. So based on the application, a suitable diameter with respect to this coil and with respect to this circular shape. So these coil springs are made with the help of special spring steel. So it is having cross section as a circular. So with desired stiffness. So with increase in the diameter of the coil, so we can increase the stiffness. So it is simply fabricated by winding it around one of the rod or the simply the bar. So this type of coil spring is formed at high temperature. So having proper heat treatment and that to various processes that can give stiffness as well as maintain its elasticity property. So then only it is possible to absorb the shock. So similar to leaf spring, here you can see this one is the main spring and this one is the helper spring. So in the same way, this is main coil spring and this one is helper coil spring. So this is used to give a progressive stiffness. So in the whatever way these helper springs are used in heavy duty vehicles or commercial vehicles, in the same way to give additional stiffness, these are provided inside the main spring. So with respect to this coil spring, you should remember that so there is one advantage with respect to the coil spring. So whatever energy stored, that means absorbed per unit volume is almost double. So and wherever space is less based on the type of vehicle, the selection of leaf spring and coil spring can be done. Again, as compared to the leaf spring, they will have these coil spring do not have noise problem. So also required a very less space for particular, if at constant load. Suppose we are going to consider springs or selection of springs, and if space is very less, then for that we can select this coil spring as compared to the leaf spring. So these are suitable for vehicle or to have better utilization of the shape and size of the vehicle, and we can make a compact unit. And sometimes we can provide a damper inside this spring as well. So that spring and dashpot or the damper will be in one single unit. So we can have that compact unit. So basically, these coil springs are going to take shear as well as bending load, and in addition to this, a damper is provided, so that will damp down the vibration oscillation or vibration amplitude. And as compared to the leaf spring, you can see here, this is one coil spring and this one is the damper which is provided. One end it is on the arm and other end is attached to the bottom side of the body. So this you can see the one side member. Okay. So leaf spring and the coil spring. So basically leaf spring are used in case of heavy duty vehicles. Some of the jeeps such as Mahindra Bolero, again tracks, tempo tracks. So on front as well as rear, so such leaf springs are provided. So depending upon the load, so number of strips are going to be changed. And such coil spring suspension is provided on cars. So on the front side there is one strut assembly, and at the rear such main coil spring as well as helper coil spring is provided. Okay. Then next type of spring, and you might have confusion regarding this spring. So it is also act as a spring. So it is called as a torsion bar. So this torsion bar is simply a bar. So which acts in the torsion. So, and as there is twisting, there will be shear stress only. So with respect to this torsion bar, you should remember shear stress will be seen. So basically this is a torsion bar at the both ends. So there are, so you can see this. This one end is connected to lower plate or lower arm, and another end is connected to the frame, and in between that there will be torsion bar. So this torsion bar is made up of heat alloy spring steel, alloy spring steel, So here this is the rear anchor and this one is the two bushings. So this you can relate with this component and this is for the rear anchor. So like that you can relate. Okay. And here there are teeths and those are meshed with this splined bush. So when the wheel will move in upward direction, here it is shown. So there will be twisting action of this torsion bar up to certain level. So it gives springing action and which also act as a suspension spring. So this bar provides its function just by resisting the twisting. So up to certain limit, it is providing the resistance to the twisting, but in some cases there is failure. So such torsion bar is used in some of the vehicles where space is less, but it is not that much popular because whatever attachment or mountings required to hold the torsion bar are having more cost. So that's why it is not popular or not commonly used as a suspension or as an element of the suspension system. So instead of leaf spring and the coil spring, it is not directly used for that purpose. So it can be used for another purpose, that is reaction member. So that we are going to see in next slides. Wait for 1 minute. Okay. So next type of spring, that is air or gas spring. So you can see carefully the figure. This is schematic diagram. So this one is lower control arm. Lower control arm. Then so just I am relating the components with actual image. So this is air spring. So basically, there is piston or sometimes diaphragm arrangement. So it is filled with gas or the compressed air. So that's why it is called as the air and gas springs. So whenever wheel is passing on the pump, so you can see or just imagine wheel is attached at this place. When it confronts any obstacle or when wheel is bounced, what will happen? So you can see this. So as here compressed air or gas is filled, so it is in action. So when wheel is moved in upward direction due to the bounce, so this is the shape of that air spring, and whenever a rebound will be there, then this is the shape or the structure of the spring. So basically these springs, a compressed air or gas is filled. So again, in practical language, you might know that this is one of the below or the cylinder. So whatever wheel moment is transferred with the help of this piston or the diaphragm. So as soon as wheel confronts any obstacle, this is the below shape or the cylinder shape. This is having a rubber material, and this is the original position of the air spring. So such suspension is provided on ST buses. Some of the Asiads you might have seen. So it is mentioned on the bus itself that air suspension system, like that, or having air suspension. So simply it is mentioned on the body of the bus. So actually one of the advantage of such type of air suspension or air and gas springs, so they are going to give high ride quality in case of independent suspension. So this can be used independently on each of the wheel, but there are certain disadvantages with respect to this air suspension system. So what are the disadvantages? So it is having high cost. So again, you can see there are many components and the lines or cables that you can see in this actual image. Then whatever components or whatever additional devices required, that will add more complexity in the suspension system. So previously what we have seen, a leaf spring, only mechanical action is required. Coil spring, mechanical action is required. But in this case, so to provide compressed air compressor is required. So whatever additional components required are more. So that will create complexity. Then there is risk of breakdown. Then it is required more maintenance as compared to the that conventional suspension elements or the suspension system with conventional suspension elements. And in addition to this, as there are number of components, these springs are bulky in nature. So additional more components, no simplicity. So that's why there is more bulk, they are more bulky in nature. So this is about air and gas springs. So mostly used in independent suspension system, that we are going to see what is dependent or conventional and independent suspension system. So this is the next slide. First of all, we are going to see types of automotive suspension system. So these are the components: leaf spring, coil spring, air and gas spring, and in addition to this, we required such shock absorber or the damper. So before that, before studying a damper, we are going to see what are the different types of automotive suspension system. So basically, there are two types of automotive suspension system. So first one is conventional one, and second one is independent. So conventional suspension system and independent suspension system. So you can see this is the conventional one solid axle, and at the two end, two wheels are provided, and here leaf spring. You should imagine, so whatever figure at the bottom side of this slide, so this is leaf spring, and we are observing from this side. So we are going to see only this part, only this part. So as this is the solid axle, so in the conventional one solid axle is there, and at the two end, two wheels are provided. So in case of the conventional system, if one wheel confronts or encounters any bounce in the road, this will tilt the solid axle. So whatever situation this wheel confronts, the effect of that will be given to this side as well. So suppose we are going to consider such body, again it is tilted. So in conventional one, so whatever situation of one wheel, so effect of that will be given to the other side as well. And in case of independent suspension system, you can compare. So there is flexible axle, so one separate arm for this wheel, one separate for this coil spring, one separately for this coil spring, and these are the shock absorber. So if we are going to consider body like this, what you are going to observe, there is no tilting of the body. no tilting of the body. Okay, so here, because of bounce will push the up by the bump, so there is shock is absorbed just by giving compressed action to this coil spring. So only effect will be localized only for this wheel only. It is not going to tilt the body. So you can see this dotted line and this dotted line. So there will be action only with respect to this wheel, as there is, this is lower arm, this is lower arm, only this side of wheel is affected, other wheel is not affected. In turn, there is no influence of pushed up of one of the wheel during the bump on the road. So that is possible in case of the independent suspension system. So this is an arrangement or independent suspension system. In brief, it is defined as arrangement wherein we can have a carriage unit. There is no effect on the carriage unit. So this is the carriage unit. So you can consider any body. So this is without any obstacle. When obstacle is there, so this side will be in action. There is no effect on this side. So that's why body remains straight. So it is a suspension system wherein the carriage unit or the frame is connected in a such way that rise, that is during the bump in the road, there will be rise in one of the wheel. So that will not affect to the another wheel. So all the passenger cars nowadays, they are using such independent suspension system. So this is the conventional one. So for writing descriptive action, such simplest figure will give better idea. So for conventional or dependent suspension system, this is also called as a dependent suspension system. So here you can see, because of this solid axle, there is tilting of body. So as there is flexible axle, so you can see this. This one is differential. So this is for the front engine rear wheel drive cars. So this is about two main types of suspension system, that is conventional one and the independent. So conventional is also called as a dependent. If one wheel is getting influence, other will be having the same effect. Because of that, there will be tilting of body. And independent means all wheels are independently suspended. So there is no effect of disturbance of one wheel to the other. So basically, there are certain advantages with respect to the independent suspension system. So it is giving more comfort to the passenger. It also facilitate less unsprung weight. So again, it also avoid more changes in the steering mechanism related angles. So, and in addition to that, it is having no tilt while the system is in operation. So it also reduces wheel wobble. So as there is no influence of other wheel, or there is no influence of each other action, so it also diminishes the wheel wobble. So again, with respect to the conventional one, it has certain disadvantages. So high cost, again greater maintenance because of more mountings or more bearings as compared to the conventional suspension system. And whatever that arms or the subframes required, those should be more rigid. So this one is the arm or support frame. This one is arm or the, this is again supporting frame. So this is the arm. So here it is, wheel will be there. So this side there is engine. So just for your understanding, here wheel is not shown, but wheel at this side, shock absorber and the spring. So now let us see the types of independent suspension system. So first one is MacPherson strut and second one is Wishbone type. So I will take break of 2 minutes. So please just see the images on the slide. So once again, we'll start. So some of the types of independent suspension system. So first one is MacPherson's strut assembly, and second one is Wishbone's type. So basically, these names are given based on the constructional features. So let us see widely used suspension system, that is MacPherson strut assembly. So this is a schematic diagram on the left hand side. So this is a wheel. This one is lower R in the form of wishbone structure, not seen in this image, but you can see this one is the wishbone structure, like this triangular shape. Then this is the strut containing coil spring, which is used to absorb the shock, and this one is the component which is called as a damper or shock absorber. And at this end, there is flexible mounting of the strut. So that can be connected to the body of the four-wheeler. And at this end and at this end, so two collars. So to mount the springs, that is this coil spring. So this is one is the schematic diagram. So this is independent suspension system. The same structure is provided for another wheel. So whatever influence of this wheel due to the obstacle, that is not given to the other wheel. So other things, this spring is used to absorb the shock only, and whatever vibration or amplitude of vibration due to the this external excitation of the bump, that can be minimized by using the damper. So that will damp down the amplitude of the vibration. So here somewhat more precise image, same is shown here. Wheel can be mounted. This is triangular link. Then this is spring inside which damper. This one is flexible mounting. Again, another one image related to the same. This is somewhat different structure of the lower R. Here it is mounting at the top. Other things are same. Here you can see the wheel, then strut assembly. So whatever function of the suspension system, it is the same, but only element and their application is different. Okay, so this is the simplest type of independent suspension system, which requires less space as compared to the other type of suspension, independent suspension system. So just I will show if image is available.
There is a rigid linkage between the two tires.
You can see this small video. So you can see once again, and just I will repeat. Okay, so my voice is audible. Sachin?
Yes, sir.
Okay, so you can see the different components in the video. So this one is double wishbone. So this is again arm they have shown. These are L-shaped lower arms. Okay. So this is something about McPherson and the wishbone. Now let us see using this schematic diagram. So this already we have seen McPherson strut assembly. Now, what are the advantages and the disadvantages with respect to this McPherson strut assembly that we are going to see? So listed is there. Okay. So advantages and disadvantages. So you have seen it is having simple in construction, so therefore easy maintenance. So less variations in wheel camber. So because of that strut assembly, then it is used in a vehicle having engine is placed at the front side. So 3 to 4 cylinder type of engine. So if engine is placed in the transverse way, so space available is very less. In that case, we have to provide a suspension system which requires very less space. So in that case, it is advantageous. Again, it is also accompanied with one of the disadvantage, that is, in order to absorb full suspension loads, the body structure has to be really strong above the wheel arches. So whatever arch is provided, so that should be strong. So what is that arch? So this is, so here there should be strong structure so that we can connect the top end of the strut assembly at this end, and other way that already we have seen. Okay, then next one is wishbone type. So it is also a simple one, but as compared to this McPherson, it requires more space. So this is also simple in construction. So one upper link or upper arm, one lower arm or lower link, and in between that there is coil spring. So you can see this on the right hand side as well. This is the spring inside which damper is also provided. Lower wishbone, and this one is upper wishbone. So whatever bump that when it will confront to this wheel, this arm will move in upward direction. Just there will be compression of this spring and rebounds will be there. So this is actual image. You can see shock will be absorbed by this coil spring and damper is provided to damp down the oscillation amplitude. And this is upper wishbone, lower wishbone, and here wheel can be mounted. Okay. So such type of suspension system is used in rambo tracks at the front suspension. So you can see advantages and disadvantages of this. So ride quality is good. Again, it also improves the steering preciseness because wheels movements are not linked. So ground clearance can be increased by using such wishbone based suspension system. But it has also some of the disadvantages, like initial cost is more, maintenance cost is more, required frequent wheel alignment. Otherwise, it leads to more tire wear. So at particular interval of time, so wheel alignment should be done in such types of suspension system. So additional maintenance cost is going to be increased. So this is about types of independent suspension system. So majorly these two are used based on the space available. You can see the various shapes of this McPherson strut assembly, and similarly the various shapes for this wishbone type of suspension independent suspension system. Now, one of the important component, that is shock absorber. So basically two major components are required for the suspension system. First one is spring and second one is damper or the shock absorber. So generally this shock absorber or the damper is a device which is used to decrease amplitude of oscillation. So the principle of operation with respect to this, so it is a device which provides its dampening action just by transferring oil under pressure through walls which restrict the oil flow. So that construction we are going to see first. What are the various components which are included in the shock absorber or the damper? But just it allows or just transfer oil under pressure through walls which restrict the oil flow. So just small opening is provided. Once that spring is going to be compressed, oil from one compartment to the another is going to be transferred with restricted entry. So, or you can see when a piston forces the fluid in the cylinder to pass through some hole, a high resistance to the movement of piston is developed because of that small hole, which provides dampening effect. So you can see a schematic figure. So shock absorber or damper, this is for the compression, and this one is for elongation. So this is lower end, this one is upper end, and this hatched portion, this is nothing but piston, and these small holes are called as valves in piston. And this one is fluid, and this one is reservoir tube, and this is cylinder piston arrangement. So this one is reservoir tube, this one is piston cylinder arrangement. So spring is not shown here because that is going to provide, that is provided there to absorb the shock. So basically we are calling that spring and damper arrangement as a shock absorber. But in that, this piston and cylinder arrangement, wherein the piston forces the fluid in cylinder to pass through some hole, and because of high resistance to the piston, there will be dampening effect. So that is created with the help of this structure, that is reservoir tube, cylinder and piston arrangement, this inside this reservoir tube. So whenever there is a compression, that means this end confronts the obstacle, so there will be compression. So this end is connected to the wheel, so piston will move in this downward direction, but whatever fluid inside this cylinder, that has to pass through these small holes. In turn, it experiences the resistance. So basically, this is with respect to the compression. Now, this is when obstacle confronts the wheel. Now, shock is absorbed by the spring. Because of that, this level in the reservoir is increased. Now, once we'll pass over that bump or pit in the road, what will happen? There will be elongation of this system is going to take place. So in that case, the piston will move in upward direction. So again, whatever fluid in the reservoir, that will pass to this cylinder, and again you can see the level inside this. But what is the exact principle? So transfer of oil from cylinder tube to the reservoir, or reservoir to the cylinder tube, that will provide a resistance to the moment of piston, and which provides the dampening effect or the damping effect. So then, so this is about the shock absorber or the damper. So generally this construction or this device is called as a damper. So absorbing the shock, that work is done by the spring. Okay. Then next one is some of the reaction members. So these reaction members are provided based on these suspension moments. So whatever body roll which is experienced during motion of the vehicle on the road. So now I have kept this image here itself. So reaction members. So here wheel is mounted. This one is a radius rod. This one is the sway bar. So side to side movement of the vehicle, it is avoided with this sway bar, or this you can call it as a stabilizer bar. So some of the reaction members, those are called as anti-roll devices. So which includes a radius rod and the stabilizer bar. So this radius rod is also called as a radius arm or torque arm, is a suspension member which is intended to control wheel motion in longitudinal direction. So it will control motion of the wheel in longitudinal direction. So with respect to some reference, so this radius rod is connected with the help of bush or with the help of bushings. So here you can see this one is the radius rod. Here it is bushing. This is another one figure, schematic one. So this is the body lower part. This one is the arch. Here, this is MacPherson strut assembly, spring, and inside that damper is there. So the link is connected with the help of bushing on one end to the axle, and on the other end it is connected to the chassis frame. So this is other end, and this end it is connected to the axle. I will show one more figure if available. So screen is visible. So I have added another slides. Okay. So here you can see typical stabilizer bar installation. Here strut rod bushing. This one is strut rod. So this part is connected to the chassis frame. This is stabilizer bar. So all these additional components are required to have better control on basic suspension movements. So that is pitching, rolling, and the bouncing. So most cars and the trucks are equipped with stabilizer bar on the front suspension system, which is made up of hardened steel and which is attached to both lower control arms with bolts and rubber bushing, called as a stabilizer bar bushing. It is also acts as anti-sway bar. That means it will avoid side-to-side movement of the vehicle. So that's why it is also called as a reaction member, and it works as an anti-sway member. Then, so how it is acting, just one example is given. So a stabilizer bar, it is anti-sway bar or anti-roll bar. So bar operates by twisting bar if one side of the vehicle moves up or down in relation to the other side. That is during cornering, hitting bumps, or driving over uneven road surface. So you can see such type of body lean. So as body of the vehicle leans because of road surface or after hitting the bumps, the stabilizer bar is twisted and the force exerted by the stabilizer bar counterattacks the body lean. So it will try to control the stability of the vehicle. So that's why it is called as a reaction member. So whatever action is going to take place due to the cornering forces, due to the hitting of the pump and or driving over uneven road surfaces. So for the action, there should be some reaction, and that is given by this anti-sway bar or anti-roll bar. That's why this is called as a reaction members in the automobile. So this is also one of the component in the suspension system. So you can see this is end which is connected to lower arm. This is the bushing which is connected to the lower side of the body. A rigid mounting that is connected to the body part. So some strong enough structure is provided. Then this one is a radius rod. Already previously we have seen this is the radius rod. This one is a rubber bushing. Other component already we have seen. So this is damper spring. So this is the damper, and around that spring is provided. So this is with respect to the damper only and other components. Okay. Then here you can see coil spring suspension and inclusion of stabilizer bar. In that, this one is the axle housing. This is coil spring. This one is coil spring. This is a damper. This one is the damper. Here, this is the stabilizer bar. Here it is a reaction member which is provided for the front wheel suspension, or in case of the independent suspension system. Then this is torsion bar. Just I will show in addition to the previous discussion. So one end is fixed to the vehicle frame. This is the end which is connected to the vehicle frame. This is a torsion bar. This one is control arm. This is strut rod. So the other end of torsion bar is attached to the control arm so that it twists as a control arm moves up or down. So that twisting action will be takes place as a result of movement of the control arm. So when the control arm is moved by the suspension, the twisting motion of torsion bar resists the unwanted movement. So this bar is also used as an anti-roll member, and in some of the cases it is used for the suspension element or for suspending or for springing action. So now just see again the same one. Here this is the damper. Here spring is not shown. So this torsion bar. So you can see so here this will act as a spring. A torsion bar is a spring which is a long, round, hardened steel bar similar to coil spring except for a straight bar. So it is also used directly as a torsion bar suspension system, or it is included in torsion bar suspension system. Then you can see how it is connected. So fixed end of torsion bar, it is at the frame, and torsion applied by the controller. When controller moves up, it will have twisting action. So this one end is attached to the lower control arm of the front suspension and other end to the frame that we have seen. When the wheel hit a bump, the bar twists and then untwist. After twisting, it will automatically untwist, and in turn, it will cue the springing action similar to coil spring and the leaf spring. So longitudinal torsion bars, you can see how suspension is accomplished with the help of the torsion bar. Here again, you can see some more details. This one is torsion bar. Okay. So after these components which are used in the suspension system, let us see the types of drive. Okay, so you can see there are two types of drive. First one is Hotchkiss and second one is torque tube drive. So basically there is a difference how that braking torque and that accelerating torque is provided to the chassis frame. So just you can see the construction of the two types of drive. This is the first one. This is frame. This one is frame. So no change. First component as it is. Then this is gearbox. Gearbox. Then a major difference related to this bracket and the shackle. So this bracket is permanently attached to this chassis frame and there is one shackle at the rear end. Whereas in case of torque tube, what you are observing at both the ends of the slip spring, there is shackle. That means this shackle is not going to take any part whenever there will be brake will be applied or that tractive effort will be provided. So in this first type, this bracket as well as the propeller shaft will take part in both the action while braking and while the acceleration of the vehicle. So that and in this that care is taken with the help of this torque tube, which is one of the casing provided on the propeller shaft. So the difference in the construction, it is clearly seen. So in tomorrow's lecture, we are going to see the advantages, disadvantages, and one short video regarding these types of drive. So what we have seen today, that just I will revise and just so we have seen types of springs, leaf spring, coil spring, types of suspension system, types of independent suspension system, which includes McPherson, then Wishbone, then shock absorber we have seen, then reaction members, which includes stabilizer bar, radius rod, how these bars connected to the arm and the body, that we have seen via visualization of various figures. So this is for today's lecture. Now just